If I have this here, what's the only real difference between those two? But what am I going to do first? Has what I do first suddenly changed? No. I still subtract that 5, right? The first thing I want to do is, where's my x? It's in this term there. So the first thing I want to do is get that term by itself. I almost always divide last, but sometimes I multiply last. Whatever the hell's on my variable is the last thing I get rid of. So the mistake a lot of you guys made was you multiplied by 2, but if you multiply by 2, you actually have to multiply this guy by 2 also. That 5 can't escape. So don't do that first, because there's too much crap going around. So the first thing we're going to do is exactly the first thing we did over there. Subtract 5. And then, what do you do? Multiply by 2. That's how we get the x by itself, right? Well, that's a nice sound for that. I like that. Every time we finish a problem, I want to hear that. All right. So is that, any other questions from the quiz? Oh, the last one? Which version did you have? You only need one mistake. I'm happy about it. Let's do something. Keep it up. Don't lose it. Can I see what mine is? I guess so. Jody? Yep. Okay. Has anybody else not got theirs back yet? Okay. Okay. Is there anything else from the quiz? Okay.
One more question.
Yeah, sure.
Okay. Page 216.
Where's that?
Actually, page 217. Number 36.
Page 217, this is section 4.1. Number which one?
36.
36. Section 4.1. So it says use exercise 34. So 34 says of the 63 employees at a certain biomedical firm, 22 are men. So 63 employees. 22 of them are men. So the first part of 36 says how many of the employees are women. So they are making a large assumption that nowadays is not always true, but you're saying that they identify themselves as one or the other, right? There's a lot of discussion about there's a third kind of gender coming out, but let's just go with 2 genders. So if I have 22 men, 63 employees, how many women do I have working there? Yeah, just subtract those. The rest of them must be women. Is that cool?
I did that.
Okay, I like it. So then part B says, what fraction of the employees are women? So how would you say it in English? There are blah, blah, women out of blah, blah, people. There are 41 women out of 63. That's exactly how you write it in math. There are 41 women out of 63 employees.
I thought it was more complicated.
No.
I did it because I didn't know if that was correct to subtract that stuff.
Oh yeah, definitely. Yeah.
I didn't know there was like they wanted for some X or something.
So what they're getting towards is if I knew that the men's fraction would be 22 out of 63. You with me?
Mm-hmm.
So of course if I add that to the women's fraction, I better get 1 whole, right? And sure enough, if I add these together, what do I get? They have the same denominator, right? So I have 22 of these plus 41 of these is 63 63rds, which is better known as one whole, right? So it makes sense. Once I break things into fractional parts, if I add all those parts back together, I better get 1, or else I did something really wrong. Yeah.
So always the big number is in the bottom?
No. But when there are certain types of problems where that will always be true. When I have something and I'm breaking it into parts, there's no way the top could be bigger than the bottom then. So if I started with 80 people and I say, well, 40 of them are Democrats and 36 of them are Republicans, and you know, I can't possibly say, well then 91 out of 80 of them are, what? How do you have 91 people doing something when you only have 80 people in the room, right? So that kind of problem, the top can't be bigger than the bottom. Are you guys kind of with me? That's the kind of problem that physically you can't have a bigger number on the top because you're cutting something into parts. Now, when you're talking about how much did our profit increase from last year or something, you know, last year you could have made $500, and this year you made $600. So I'm not taking like the profit I made last year and cutting it into parts. I'm comparing two things. You with me? Or even that last problem that I just erased, which was 22 men and 41 women, right?
Right.
What's the ratio of women to men? Don't think too much about that. It's exactly what it sounds like. Ratio of women to men. 41 to 22. Exactly. Right? So again, in that case, I'm not looking at the parts. I'm looking at how do the parts compare to each other. So it depends on the kind of problem I have, if the top is allowed to be bigger than the bottom. You guys kind of with me? Mm-hmm. So sort of that old thing about you can't actually give more than 100%. Because once you're at 100%, you ain't got nothing else. But in sports, it's all psychological. Give that 110%, you're like, yeah. But math says, oh yeah, that's crazy. Sorry. Yeah.
So can this now be vice versa?
Sure. If I said ratio of men to women, I would have turned it around. Yeah.
Okay.
You with me? Definitely. In fact, if anybody familiar with odds, you know, if you go to any horse races, even just to watch the horses run around, or maybe to lose some money. I got way too much money. Let me go to horse races. Odds are ratios of normally the ratios of how many times a horse would lose to how many times it would win. Right. So if you have a ratio of 30 to 1. Out of 31 races, the horse would lose 30 times and win only once, and that's why you would make a lot of money if that horse won and you bet on it. Are you guys still kind of, everybody's at least looking this direction. So because like, I don't care about horse racing at all, but did that make sense? So it's an example of a use of a fraction in the real world where the top could be bigger than the bottom, because you're not comparing parts of something. Okay, maybe. Yeah.
I have a homework question. Page 241, number 1. I think I might have missed that part. It's the multiplying of fractions.
We haven't done that yet officially.
Oh, okay, good.
Don't worry.
Then I'm good.
We haven't done. We officially did 4.1 and 4.2.
Okay.
We have not officially looked at 4.3 yet.
Okay.
Yeah.
I'm ready.
So it's okay to have a question on number 1 because we haven't even done this section. Any other questions from homework?
Yeah, 39. Percentage.
39?
Uh-huh.
In which section? Sorry?
Some section, 41.
4.1, okay. Because I was just somewhere else. So 39. The one about the hurricanes? Right? Okay. So 2005. 2005 is when I moved here. And everywhere I lived before, hurricane season actually meant something. Here, it really doesn't. You're like, it's what? It's fire season? Yes, that you understand. But now I'm actually the same way. But in 2005, there were 28. That was a good year to move here, actually. 28 tropical storms. There were 15 of which turned into hurricanes. what fraction of the 2005 tropical storms escalated to hurricanes? So again, how do you say it in English? How would you say it? 15 hurricanes out of 28 total storms, right? So it's exactly how you write it in math. 15 hurricanes came from 28 total storms, right? Let's try to be 28. You with me? So if there are 43 people in here, and out of that there's 27 women, what fractional part of the classroom is women? Yeah, 27 out of 43. What fractional part is men? Good. 43 minus 27. 16 men out of 43 people. Good. And of course, when I add these together, I have to get 1 because I got the 16 from 43, so it sort of has to add back up to 1. All right. So the basic idea of a fraction is, and this is not always true, like you just said, because the top could be bigger depending on the way you put it together, but a very basic type of fraction is part divided by whole. Right? Now we know we can make fractions out of other things, but one of the more common uses of fractions is part out of whole. Okay. And that would be just like this. Only 15 of them became hurricanes out of 28. Now, later in the book, we're going to talk about how to turn that into a percentage, which is actually, when I say, if I told you, what is that roughly? Now you're getting the territory you don't want to get in. Let's say that's roughly, 58%. If I said 58% became hurricanes, even if you're not good with percentages, that makes more sense to you than if I said 15 divided by 28 became, that doesn't make inherent sense to us. So percentages are humans' way of making this math make more sense to us. Right? We created them. We said, let's make everything out of 100. And then we can relate to it. If there's a 2% chance that this surgery you're going to have is going to kill you, it'll still freak you out, but it's better than 28% chance. Right? It gives you a way of comparing things. It makes it make sense. That's later. Okay. Anything else from the homework?
I have another one. The prime factorization.
Good. All right. That's the one
230.
piece that I didn't get to.
Page 230.
Page 230. And in general, we'll just talk about prime factorization in general. What kind of a number is a factorization? What kind of a number is a prime number?
Is that like 1 through 10 or something like that?
So far it sounds like odd numbers, but you are right so far, right? We'll go further. I like it. What is it about those numbers that make them prime? Yeah, the only way you can break them up is 1 in itself. So like the number 17. If you try to break it up into parts, you can't, right? And when I say parts, I mean two whole numbers. You can break that down into 2 and 17 halves, but that's not very useful. So the only way I can do that is 1 and 17. You guys, hopefully most of you guys know this. That's the definition of a prime number. And actually there's this huge push to try to find a pattern in the prime numbers. They haven't found that yet, and there have been all these mathematicians looking for it. So if anybody ever found it, they would instantly become this huge celebrity, at least in the math world, which means nothing to the rest of the world. The opposite of a prime number, like the other piece to this, is called composite numbers. And that would be a number like 18. How can you break 18 up? 2 and 9 and 11. Now which one of those is prime? 2 is prime. 9 is 3 and 3. So this is what they mean by prime factorization, is take a number and break it up into nothing but prime numbers. So this is a list of prime numbers that multiply to become 18. So every single composite number can be broken down into a different string of prime numbers, right? Nobody else could have this same factorization because when you multiply that, you get 18. It can't be any other number. So you guys try this one. Break this number down all the way. Do the prime factorization of this. What you got, Jeff? I don't know. So just like we did that one, do that one. Do it with yourself. Don't say it out loud. Very often your first step could be very different from the person sitting next to you, but you're eventually going to get to the same exact place. Doesn't really matter how you first do it. Maybe don't do 1 times 48. Doesn't really matter. Somebody help me out. What's the first step you did? See right there, I love it. So you could do 6 times 8. You could do, what's another one? 2 times 24. You could do, what's another one? 4 times 12. You could do the one that I would think less of us would realize is, I love it, 3 times 16. I got a little bit overexcited there, but I'll be all right. So I can do 48 is 3 times 16. Now, every single one of these, let's just pick one of them. This is the first one I heard. Are either one of these prime? No, because 6 is 2 times 3, and 8. Now that's a prime, that's a prime, that's a prime. 4, 2 times 2. So what is the prime factorization of 48? Yeah, 2. I like it. Let me get there. 2, 2, 2, 3, which is better written as 2 to the 4th times 3. See, our exponents come in and save our ass, right? I don't want to write 2 that many times. I'm just too lazy. Although I did. But 2 times 2 times 2 times 2 is 2 to the 4th. Is that cool? That's what a 4th power means, right? So anywhere I see 2 times 2 times 2 times 2, I can replace it with 2 to the 4th. They mean the same thing. Are we cool? A few of you guys look like, why did exponents come in here? Because anytime I see this, I can replace it with that because that's what that means. So any of these, if I do this, this is a 3. 16 is, all right, 2 times 8, 2 times 4, 2 times 2. There's 1, 2, 3, 4 2s, and 1 3. Any way I start, I'm going to end up with 4 2s and 1 3. Okay. Is that cool? The strangest reactions.
So the answer is going to be the 2 to the 4th times 3.
Yeah. You could write it like that. I'm cool with that. But even better would be that. All right. So try one more of those.
Reverse that too, right?
Say again.
3 times.
Oh yeah, sure. You could write it as 3 times 2 to the 4th. Either way, because multiplication doesn't care which way you do it. So you try this number out here. Let's see what you got, Jeff.
46.
That's a little evil. Okay. It's not really that evil. You remember that thing we talked about last time about checking to see if a number goes in?
This would be the composite, right? Or
Yeah,
is this...
48 is a composite number.
Okay.
Its prime factorization is
All of
that.
that. Okay.
Yeah. Almost.
Yeah.
Not 9.
8.
Good. So 3 definitely goes in because 3 goes into 24 and 3 goes into 3. And also 2 plus 4 is 6 plus 3 is 9. It's multiple through. So 9 would go in also. But 3 times 81, I like it. 3's prime. So you circle that dude.
9.
9 times 9, and each 9 is, so what is 243? It's 3 times 3 times 3 times 3 times 3, or 3 to the 5th power. I love it. Okay, maybe. So that's the idea of prime factorization. So the first big chunk of homework is to do that in that section. This is section 4.2. Okay. So anything else from homework? Yeah.
Number 15. Percentage.
Sure. So you gotta be quick.
I'm sorry, on page 230, number 36.
All right, so we got 230, 36, and what was the other one?
230, 15.
230, 15. Okay. Oh, so real quick, 15 is like what we just did, but it starts with this number, right? So what can you always do? What is it about this number that tells me what will definitely go in? 2 will definitely go in because it's even, right? So if you divide by 2, it's easy. 4, 1, 4. Does 2 go in again?
2.
Yeah, it's even. So 2 goes in
207.
207. Good. Now you get to 207 and you're like, what the hell, man? But 2 plus 7 is?
9.
So what will go into 207?
3.
3 or 9, right? So if we do 3 goes into 207, what would you get? 6. 69, good. And now how do you break that up? Again by 3, because that's still a multiple of 3 there, right? 6 and 9 is 15. 23, I like it. And then 23 is prime.
Yeah.
Good. So how do I write that a little more concisely?
2,
2,
3 to the 5th.
2 squared,
Yeah, 3 squared.
3 squared,
23.
23, I like.
Yeah.
So prime numbers do not have to be small. The largest prime number found so far, if I remember, has like 70 some odd digits in it. Right? So they keep looking for the next biggest prime number. Believe it or not, there are people doing that. There's actually computers doing that, to say honestly, just chunking away and they go, I found one. That's just going to make them rise up against us eventually. Now, what about 36? So this one here? Ah, okay, I got you. So see how I didn't even think about it. So you can either represent it like this. This number is the same thing as this number, which is the same thing as this number. Conventionally, you would never see this. You would always either see it on the top or out front, but they all represent negative, whatever the hell that is. So that's why the negative, it's whatever your answer is just going to be negative, and then you worry about how does that reduce. So what goes into both 28 and 60? All right, good. So if you saw just 2, right? 28 divided by 2, 14. 60 divided by 2. They're still both even, so I can do it by 2 again. The negative is still there. Good. 7 15ths, and that they don't share anything. 7 and 15 don't have anything in common, so I stop. That's when I know I'm done, is when the numbers don't have anything in common anymore. But you can do it in multiple steps. You could have, I think a few people said 4. 4 goes into both of these, but if you don't see that, just do what you can see and then just take another look. Can anything else go in? Did I go far enough? Right? So don't just do one thing and stop. Make sure that you've gone far enough. Okay. Because from now on, if you give me a fractional answer like 6/8, I'm going to take points off. Even if that's right, it's not in the right form. You have to reduce that to 3/4. Then that's the right answer and the right form. Okay.
Do you have to see the work? Can I just go from 8 to
At that point, I'm cool with just doing that. I'm with you on that.
Okay.
You should be able to do 6/8 to 3/4 without showing any work. But if I give you 415 over 65, I need to see something. Yeah. Okay. Is there anything else before we continue? All right. So this is kind of cool. So in the questions I did the one thing that we didn't do in 4.2, which is the prime factorization stuff. 4.3